this video, we will discuss about maximum matrix sum. You are given an n cross n integer matrix. You can do the following operation any number of times. Choose any two adjacent elements of matrix and multiply each of them by -1. Two elements are considered adjacent if and only if they share a border. Your goal is to maximize the summation of matrix elements. Return the maximum sum of the matrix elements using the operation mentioned above. So what they are saying is that in the input, we are given an n cross n matrix, right? Now, in one operation, we can take any two adjacent elements, right? We can take any two adjacent elements and we can multiply them by -1. And this operation can be performed any number of times, right? Now, what we need to do is that we need to maximize the sum of all the elements of this matrix, right? Meaning we have to make as many elements as positive so that we can maximize the sum of the matrix, right? Now, if we see for this particular matrix, so we have two negative elements here, right? So now what we can do is, so we can, if we consider this particular -1, then for this either we can multiply these two adjacent elements with -1 or these two adjacent elements, right? So let us suppose we did for these two, then what will happen? That the matrix will become -1, 1, -1, 1, right? Now again, you can perform the operation on these two adjacent elements. Then what will happen? Then the matrix will become 1, 1, 1, 1. Now in this case, the sum of the matrix elements will be 4 and this is the maximum sum that you can achieve out of this matrix, right? See, we need to maximize the sum, right? So we will try to make as many elements as possible in the matrix to be positive, because then only our sum will be maximized, right? And if we would have considered this -1 and 1, in that case what would happen? The matrix would have looked like 1, 1, -1, -1, and then you would have considered these two and again you would have got the same result. So this is the maximum sum that you can achieve. Now let us consider another scenario where the matrix looks like this: -1, -1, -1, 1, right? Now in this case, either we can take these two adjacent elements or we can take these two adjacent elements. Let us suppose we are taking these two. So in that case, our matrix will become 1, 1, -1, 1. Now still there is one element which is negative. Now for this, the adjacent element is this one and this one, right? Now when you will consider any of them, then what will happen is that this will become positive, but the other one will become negative, right? If you have considered these two, then in that case, this will become positive, but this will become negative. Now for this also, you would have to consider this or this. If you are able to convert this to a positive, then either of them will become negative, right? So then that means in this particular case, we cannot convert this -1 to a positive number, right? So we have to deal with it. So in this case, the sum will be 1 plus 1 plus 1, that is 3, and 3 minus 1, that is 2, right? Now let us consider another scenario. That let us suppose our matrix looks like this: 2, 3, 5, 7, -1, 6, -3, -2, 4. Right. Now, in this case, again, these are the negative elements, right? You can make these two positive. These are adjacent, right? You can make these two positive. So the matrix will look like this: that 2, 3, 5, 7, -1, 6, and 3, 2, 4, right? And then if you will see for this -1, the adjacent elements are 3, 7, 2, and 6. If you will consider any of them, then this -1 will become positive, but the others will become negative, right? So then that means in this case also, we cannot make all the elements as positive. There will be one element that will remain negative. But if let us suppose this 7 was also a -7, right? It was also negative. In that case, you would have converted all. Right. So can you notice one thing here, that whenever there were even number of negative elements, in that case, we were always able to convert all of them to a positive number. But when our number of negative elements were odd, right? In that case, there is always one element which is remaining as negative. We cannot make it positive in any of the case. We can apply this operation any number of times, but any number of times if you apply, you will never be able to make this one negative element as positive, right? So we have concluded two things: that when the number of negative elements is even, in that case, we are able to convert all the elements to positive elements. And whenever it is odd, whenever the number of negative elements in the matrix is odd, in that case there is always one negative element remaining, right? So this is the conclusion. So can't you just count the number of negative elements and check whether it is even or odd? So if it is even, then that means we can convert all negative elements to positive elements. So in that case, what will be your sum? Your sum of the matrix will be equal to the sum of all the absolute values in the matrix, meaning 1 plus absolute of minus 1 plus absolute of minus 1 plus 1. So that will be 4, right? So with this, you will be able to identify the total sum of the matrix, right? And that will be your answer if the negative elements are even. But when our negative elements are odd, in that case, what you will do? So see, we are saying that there will always be one negative element. Now, what should be that one negative element such that the sum of the matrix is maximized? When this negative element is the smallest element of the matrix or the smallest absolute element of the matrix, right? So if we consider this particular matrix, if let us suppose at the end I can consider this one as negative and there is one another scenario where I'm considering this 7 as negative, then what will happen? That when 1 is negative, in that case your sum will be sum minus 1, right? But when it will be negative 7, in that case it will be sum minus 7, somewhere around, right? Because here 7 is contributing more towards the sum as compared to 1, right? That is why this negative element should be the smallest absolute value of the matrix so that we can maximize the sum, right? So this should be the minimum absolute element, right? So what you can do is that you can identify that what is the smallest absolute value in this matrix. So this will give you 1, right? And with this 1, you can identify the sum. So see, what I am saying is that we will identify the sum of all the absolute elements of the matrix, right? And then we will check the count of negative elements. If it is even, we will directly return that sum. But if it is odd, then we need to remove the contribution of this negative element from our sum, right? And how are you going to do that? So let us suppose I found out the sum of all the absolute values from this matrix and this came out to be sum. This is a variable which stores that sum. Now from this sum, we need to remove the contribution of this negative element, which is the minimum absolute element. So minimum absolute element from this matrix would be 1, right? Now, when you would have identified this sum, at that point, you would have added 1 in your sum, right? You would have done 2 plus 3 plus 5 plus 7 plus 1, right? Because we are taking absolute values. So in your sum, 1 would be added. But since at the end, this one is not positive, it is negative, because our negative elements are odd, so this one will be negative. So I should remove its contribution from the sum, right? So this was the contribution that we have removed. But now this value, sum minus 1, this will be equals to the sum of 2, 3, 5, 7, 6, 3, 2, 4, right? But not this minus 1, right? So you will have to again do a minus 1 in this because we need to find out the sum of all elements of the matrix, right? So this minus 1 also we have to do from the sum, right? So basically, whenever our negative elements are odd, in that case, first we need to remove the contribution of mini in the sum that we had calculated. And then since it is going to be a negative element in the final matrix, we need to subtract that as well from the sum. So we can say that the sum will be sum minus 2 into mini. Can I say that? You can say sum minus mini also, but since you are doing it 2 times, we can write it as sum minus 2 into mini, right? So if the negative elements are even, then sum will be our answer. If it is odd, then sum minus 2 into mini will be our answer, where mini is the minimum absolute element of the matrix, right? So I hope you got it. So let's quickly code it out now. So first of all, we will create a variable sum which will store the sum of all the matrix elements. Then we need a variable to store the minimum absolute element. So it will be int max initially, right? And we also need to count the number of negative elements. So we will take a variable negative whose initial value will be 0. Then let's iterate inside the matrix. So we will run a for loop and it will give us each row one by one. Now in this each row, we want the value, so int val in row, and then we will add its absolute value in the sum, right? So sum will be plus equals to absolute of value, right? And then if the value is a negative number, then we should increase our negative by 1, and we should also update the minimum absolute element. So minimum will be equals to minimum of mini comma absolute of value, right? Now at the end you can just check that if negative modulo 2 is not equals to 0, meaning if the number of negative elements are odd, in that case from the sum subtract 2 into mini, right? And at the end you can return the sum, right? So let's quickly run this. So if you see, this for loop will run equal to the number of rows, and this loop will run equal to the number of columns. So if let us suppose number of rows are n and number of columns are m, so the overall time complexity of this code is going to be order of n cross m, right? So let's quickly submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.